On a certain map, a distance of 1.5 inches represents 30 miles. Calculate the distance between two cities that are 4 inches apart on the map. We're going to start with our let statement, and the thing that they ask us to find is the distance between the two cities in real life. They tell us that the distance on the map is 4 inches. We need to know the actual distance between these two cities. So let's let the real life distance between the cities be x. Now, this is one type of problem that is solved using proportions, because whenever we have a map, the goal of the map is to accurately represent what's going on in the real world. And so all of the distances have to be proportional on the map as they are in the real world, or the map won't actually represent what's going on. So anytime things are proportional, we know that we're going to be doing a proportions problem. And the way that I solve proportions problems is I start out by organizing all of my information in a table. So here's my table. It's a 2x2 table. That's how we solve proportion problems. I'm going to label the columns based on the different types of information in this problem. So if we look through, we see that there's distances in inches and then also distances in miles. Now those distances in inches are distances on the map. So we have distances on the map, and those are measured in inches. And then we also have the distances represented in miles. Those are the distances in real life. So we also have the real life distances, and those are measured in miles. Now, if we look at the problem, we're told it in the beginning, on a certain map, a distance of 1.5 inches represents 30 miles. That's the key to the map, or the legend. I'm going to write key. Every map has some sort of a key that tells you what a distance on the map represents in the real world. So with these problems, we're always going to have the key. And then the other situation we have, if we look at the next sentence, calculate the distance between two cities that are 4 inches apart on the map. That's kind of the second scenario. We have these two cities, and we're looking for the distance between them. Let's see if we can fill in this table. On the upper left-hand side, we want to know what the key says about inches on the map. And we can see that the key tells us 1.5 inches is actually 30 miles in real life. So we can go over to the real life column and put 30 there, because 1.5 inches on the map corresponds to 30 miles in real life. Now, when we move down to the cities, we've got the cities in the lower left-hand corner, the cities, and we want to know what the distance is between them from the map. And we're told that the distance between the two cities is 4 inches on the map, so I'm going to put 4 there. And then in the last part of the table, that corresponds to the real-life distance between the cities. And because we don't know that, we said that that was going to be x. Now, the major benefit to using this table is that once we filled in the table, we can move the numbers down and put them in the proportion exactly where they are in the table. This gives us 1.5 over 4 equals 30 over x. And once we have the proportion, we can solve for the value of x. Now, we can solve proportions by cross-multiplying. So I'm going to take 4 times 30, and 4 times 30 is 120. And that's equal to 1.5 times x, which is 1.5x. Now, if we want to get x alone, we have to get rid of that 1.5, and we have to divide by 1.5. And 120 divided by 1.5 is 80. So we have 80 equals x. We can go back up to the let statement now. We said, let the real life distance between the cities be x. We've seen that that's 80. and the real-life distances are measured in miles. So when they tell us to calculate the distance between two cities that are 4 inches apart on the map, we can say the two cities are 80 miles apart. And that's our final answer.